insoluble salts. Those methods that we looked at last time, they were just preparing insoluble salts. For example, calcium chloride. We talked about methods such as neutralization and displacement, all those methods. Right? Now, one thing you need to know is that insoluble salts are prepared by a method called precipitation or double decomposition. Right? Now, we need to understand what is meant by precipitation, right? Or what happens during precipitation. What happens is that two soluble salts, right? I hope you know the soluble salts. Last time we looked at it, the solubility rules. You find that two soluble salts in aqueous state, right? They will react. When they react, they will produce the salt which is soluble and the other one will be insoluble. And if you want to understand precipitation very well, you must know the solubility rules. The solubility rules will help you to understand precipitation. For example, when you have soluble salt A and soluble salt B, when they react, they will give a soluble salt C. This soluble salt A, which is C, and insoluble salt D. That's what happens. Now, let's look at an example how this happens. We have sodium sulfate and lead to nitrate. Then they form sodium nitrate and lead to sulfate. So lead to sulfate, this one is in solid state. As I told you last time that all insoluble salts are in solid state, except soluble salts. For soluble salts, they are in aqueous state. Now, what happens here is that there will be the exchange of cations and anions. That's what happens here. You see, this sodium, for them to come up with this product, let me expound it for you. We have sodium sulfate. It reacts with the lead to nitrate. What will happen here is this. You have seen this sodium. It is going to replace lead. The lead is going to replace sodium. In fact, here they have just the exchange of their positions. Where there was sodium, there will be lead. And where there was lead, you find that there will be sodium. Now, what will happen here? You write sulfate and we have lead. Now, what's the valence of lead 2? They say lead 2 has a valence of what? 2. This one has a valence of what? 2. Since the values are the same, you can find. That's how they came up with this. Even if you interchange with this one, because stays here, this one stays here, just the same thing. So, when we come to some nitrate, when they were exchanged like this, the values of this one is what? 1. And this 1. Since the values are the same, you cancel. Then you have sodium nitrate plus lead to sulfate. So lead to sulfate is an insoluble salt. How can that this is an insoluble salt? Remember, the solubility rule says all sulfates are what? Are soluble, except what? Barium sulfate and lead to sulfate. These salts, they are insoluble. Because it's insoluble to what? In the solid state. And this insoluble salt, we call it the precipitate. That's what we call it. So this is what happens in double decomposition or precipitation. So since we are looking at how we prepare insoluble salts. So the method that we use to prepare an insoluble salt is precipitation. Now, let's look at a question or how they twist questions on precipitation. Here they are saying lead to iodide is an insoluble salt. And question A says, state the method by which it is prepared. Let me erase this part as I will be explaining this to you. So, what method is do we use to prepare lead to iodide? Okay, try. The method it is precipitation. That's salt that you would think of, it should be an iodide. When they say iodide, meaning it has this element iodine, and the other salt should have the element lead. So, according to me, the salt that we can use, there can be many. Maybe when you try to use it, lead to nitrate and potassium iodide. When you use these two salts, we will be able to get lead to iodide. So, lead to nitrate, it is like this. We react it with potassium iodide. Now, the salts, since I told you in precipitation, the salts that react to form an insoluble salt, they are always in aqueous state. So these are soluble salts. Even this is a soluble salt. What will happen? Here, there will be the exchange of ions and of cations and ions. But it's also the simplest way of writing this in ionic form. Now, let's do this. You have seen this lead. It is going to replace this one. And this potassium is going to replace it. In fact, they will exchange their positions. Where there was lead, there will be potassium. And where there was potassium, you have lead. So this means that potassium will react with what? Nitrate. The valence of potassium is 1. This one. Since the valences are the same way, as well, then you have full potassium nitrate. Now, according to solubility rules, is potassium nitrate a soluble compound or an insoluble compound? According to solubility rules, it says that all nitrates are soluble, they can dissolve. So because it's a soluble salt, it will be in aqueous state. Then what other you have done is leading to iodide. So now this lead replaces it. Now this one, iodine. Then we have now lead. This one has a valence of 2. This valence 1. When we extend the valences, we have lead 2 and then 2 there. Yeah, it will be like this. Lead to iodine. This one, it's an insoluble salt to in solid state. Kind of the question they said, lead to iodine is an insoluble salt. Now, after that, what are you going to do? The next step that you are going to do is to split the compounds which are in aqueous state into what? Into ions. So now, for lead, it will be like this. Oh, wait. Before we do that, I had forgotten something. Now, we need to ensure that the equation is balanced. Is it balanced? Let's try to balance this one. So we have lead to nitrate, like this, and potassium iodide. Then we have this one, which is in aqueous, plus lead to, this one is in solid state. Now, let's try to balance this equation. Here, we have 6 atoms of oxygen, and here we have 3 atoms of oxygen. What if we try to put in 2 here and here? Is the equation balanced? 1 atom of lead this side, 1 atom of lead this side. Nitrogen here, we have 2 atoms. This 2 which is in front of the brackets, it means that this number sign inside the bracket, they multiplied by this 1. So here you have 2 atoms of nitrogen, and here 2 atoms of nitrogen. What about the oxygen? Here we have 6 atoms on the reactant side. What about on the product side? We have also 6 atoms. Compared by this, we have 6. Potassium 2, and here 2. Iodine 2, and here 2. So the equation is in balance. After balancing the equation, you start splitting the compounds which are in aqueous state into ions. What is the ion for lead 2? Since there's a valence of 2 and it's a major to be positive, then you write in aqueous. plus. These two you have seen to be written in front of nitrate like this. Nitrate has a negative charge. Then we also split potassium. Right? Potassium is like this with a positive plus 2 with a negative. Then we have now, this is an aqua state.
Yes.
We have this. Aqueous plus 2 nitrate. Then plus this one is in solid state, so it won't be split. After that, you are going to cancel out the spectator ions. The spectator ions, these are ions which appear on both sides of the equation. Right? So we cancel this and this side. We also cancel this and this side. So after that, you rewrite the equation without the spectator ions. Then we have also iodine, which is not a spectator ions.